Okay, so this week we're gonna start a new chapter, which is phase plane. Okay, so in the last week we have discussed a 2D system, but that's a linear system. Here we are going to do a non-linear system. So this is the general form of representing the 2D system, where x1 and x2 are two state variables, and this equation will tell how x1 and x2 are going to evolve. Okay, the same thing we could write it as a in the vector notation. Okay, so now here what we are interested in is, for a given initial condition, say x1 naught and x2 naught. Okay, and for that initial condition, how the state variables are going to evolve as a function of time. So that's what we are interested in. Okay, so for a given initial condition, we need to know for next time step what is my x1 and x2, and after a while what's my x1 and x2, and if I in an x1 x2 plane, if I join all those state variables, the state variable which is varying as a function of time, the x1 x2 which is varying as a function of time, then that will form a line, okay, a curve in the x1 x2 plane, and that line is known as trajectory, okay, which we have seen in the earlier week video as well, right? So that's known as trajectory, and if we have trajectory from all the initial conditions or many initial conditions, then it will give a picture of how, for a given initial condition, how the fate is going to be. Okay, and that picture with a lot of trajectories which represents various the trajectory of various initial condition is known as phase portrait. Okay, so in this chapter we are going to discuss how the phase portrait will be constructed. Okay, so one method, we could try solving this equation analytically, but mostly it is not possible to solve it, and we can't have a closed loop solution. So we have to go for a numerical method. At least it will give an approximate solution. And how do we do that? We use methods like Runge-Kutta method. So this is a Runge-Kutta method, or Euler method if the computation of Runge-Kutta method is tedious. Okay, so we have various methods, and if we use that method, maybe we'll get a phase portrait like this. Okay, so in that from the phase portrait we could say that, okay, this is an equilibrium point, this is one equilibrium point, there's one more equilibrium point. Okay, and we could also say that if this is, say this is going to be my initial condition, then I'm going to have a fate, the system is going to have a fate like this. Okay, at the same time, if the initial condition is here, it's going to be like this, and if the initial condition is slightly different from this position, so instead of here, if it's here, then it will go like this, or it will, from if it's here, then it will go like this. Okay, it will be just circling. So we could say all the stories if we could construct the phase portrait. Okay, so in the further videos we will discuss how to construct this phase portrait. Okay, thank you.